So today we are going to start October-November 2021 paper 2-3. Okay. So let's start with question number 1. Sulfides are compounds that contain sulfur but not oxygen. Yes, because ID, yes, it means that the anion have a sulfur with a 2- charge normally. And here we have a carbon disulfide. They have provided you the formula as well, CS2. Is a volatile liquid at room temperature and pressure. State the meaning of the volatile. So volatile means you can say any liquid which evaporates quickly. Then they are asking, draw dot and cross diagram of CS2. So if you look at carbon, carbon is in group 14. And if you look at sulfur, it's in group 16. So 4 valence electrons and 6 valence electrons. So carbon needs 4 more. So what carbon would do? Carbon share its 1 and then 2 electrons with this 1 sulfur, and rest of the 2 electrons with the other sulfur. And as sulfur is in group 16, it have a 6 valence electron. So each sulfur atom shared its 2 electrons. So left with 4 electrons. So I would make a 2 lone pairs over here and over here. Is this clear to everyone? Now suggest the bond angle in the molecule of CS2. So if you see in CS2, there is no lone pair and only 2 bond pair. That leads to the linear shape, and then the bond angle is 180 degrees. So here you would write 180 degrees. Is this clear to everyone? Next, CS2 is a liquid at room conditions while CO2 is a gas. Explain what causes the difference in the physical properties between CS2 and CO2. So it clearly means that CS2 have a stronger intermolecular forces, and the strength of the intermolecular forces actually depends upon. Yes, it depends upon
Number of electrons.
Number of electrons. Very good. So we can write that CS2 have more number of electrons so there are stronger induced dipole between CS2 molecules. Is this clear to everyone? Okay. Now, B part, the enthalpy change of combustion of CS2 is represented by the following equation. Here I have defined the enthalpy change of combustion. So we can define as it is the enthalpy change when 1 mole of substance burn in excess oxygen. Further right, okay, 1 minute. Don't need to write standard conditions because they have asked you enthalpy change of combustion over here. They didn't ask you the standard enthalpy change of combustion. Okay. Now,
अगर हम लिख देते हैं अंडर स्टैंडर्ड कंडीशंस तो मसला तो नहीं होता.
it can be, it depends upon the examiner. Sometimes examiner, detect the vague marks, the vague statements, or the statements which are not applying on the condition provided, then it can be penalized. So better to don't write it because here standard is missing in the prefix of the enthalpy change of combustion. Okay.
Okay, sir.
The table shows the enthalpy changes of the formation of CS2, CO2, and SO2. Use the data in the table to calculate the enthalpy change of combustion of CS2 in kilojoule per mole. Okay, here I have an equation for the enthalpy change of a combustion of CS2, and I have to figure out its enthalpy change, right? Okay, so first write the equations. So CS2 plus O2 forming carbon dioxide, CO2, and SO2. To balance this, I have to put 2 over here. So 3 moles of oxygen over here. Is this clear? Now they are provided you the enthalpy changes of formation and formation. In enthalpy change of formation, the reaction that occur always have elements as their reactant. So I would put the elements over here: 1 carbon, 2 sulfur, and 3 oxygen. So here CS2 is being formed. So I would write minus 394. Here CO2 and SO2 both would form. So for CO2, no, sorry, it's CS2.
Positive 89.
Yes, it is positive 89.7. And here you go, negative 394 plus twice of negative 297. Okay, and this is X. So if you look at the arrows, you can easily make the expression that positive 89.7 plus X gives you minus 394 plus 2 times minus 297. So if I make the X subject, then it is minus 394 plus 2 times minus 297 minus 89. So can 0.7. So can anybody solve me and tell me the answer? Yes, can anybody solve and tell me the answer?
सर इसमें हम वो इनडायरेक्ट या डायरेक्ट रूट वाला नहीं करते तरीका.
That's what we did. See, this is the direct route and this is the indirect route. That's why we have added these two and equate with these two.
ओके सर.
Can anybody tell me the answer? Yes, can anybody tell me the answer?
One second, sir.
Okay.
Sir, minus 1080.
Minus
Minus 1080.
minus 1080. Okay. Next part. Hydrogen sulfide gas H2S is slightly soluble in water. It acts as a weak acid in aqueous solution. What is meant by the term weak acid? So weak acid means it dissociates partially. Okay. Give the formula of the conjugate base of H2S. So it's very easy. When H2S undergo reaction, it loses a H, forming HS negative. So this HS negative is its conjugate base. Is this clear? Yes, is this clear to everyone?
Yes.
Yes,
Okay. Now next part. H2S reacts slowly with oxygen dissolved in water. The reaction is represented by the following equation. Okay. Explain with a reference to the oxidation number why this reaction is a redox reaction. So first we need to put the oxidation numbers on each of them. This must be 0 and this must be 0, right? So here it is -2 and here it is +1 times 2. Here sulfur is -2 and it's +1 times 2. Okay. So we can write that the oxidation number of sulfur is increased from -2 to 0. Hence oxidation the oxidation number of oxygen so it decreases from 0 to -2. Hence reduction. Yes, is this clear to everyone? जी यहाँ तक क्लियर है सबको?
Yes, sir.
Okay. Now next part. The compound AS2S3 is a common mineral. Is heated strongly in air. It forms the mixture of products as shown. Okay, here we have a equation as well. The sample containing 0.198 gram astatine sulfide is placed in 0.1 mole per dm cube of pure oxygen and access in a reaction chamber connected to gas syringe at room temperature. Okay, the reactants are heated until no further change is observed. The products are then allowed to cool to room temperature. Calculate the volume in decimeter cube of a gas present at the end of the experiment. Okay. So we have to calculate the volume in dm cube of a gas present at the end of the experiment. The molar volume of gas is 24 dm cube per mole under these conditions assumed at the pure pressure is constant throughout the experiment. Okay. So give me a minute. Okay. Can anybody have access to periodic table? Then you can find the moles of first As2S3. So its mass is 0.198 grams. Yes, can anybody tell me its MR?
Sir, 246.
Sorry,
246.
246. Okay. So here we get the number of moles. Yes, what would be the answer?
Sir, 8.05 times 10 to the power minus
8.05 into 10 raised to the power minus 4. Right?
yes.
So here we got the moles of As2, S3. Now find the moles of oxygen. Oxygen,
सर रेशियो मेथड से आएगा ना
yeah, or otherwise we have its volume. So we just divide it by 24. Because see, the volume of oxygen gas is provided.
सर वैसे can't we like compare सर हम AS2S के मोल्स और SO2 के नहीं कंपेयर कर सकते 2:6 लेकर
No, first we have to identify, because see, the amount of both the reactants are given. So first we have to identify which one is the limiting.
ओके सर
सर उसने ऑक्सीजन का एक्सेस बताया हुआ है
Okay. Okay, very good. Thank you.
हाँ
Yes, so there's no need to do this. If the oxygen excess is mentioned, yes, I overlooked over here. So there is no need to this. So it means that now we relate As2, S3 with SO2. So S2S3 with SO2. If you see in the equation, the mole ratio is 2:3. So here we have 8.05 exponent minus 4 moles.
सर 1:3 होगा.
Yeah, either you can do it 2:6 from the equation as there is 2 and 6, or you can do 1:3 and make it x. So x would be equal to 8.05. Exponent minus 4 multiplied by 6/2. Yes, can anybody tell me the answer?
Sir, 2.415 times 10 to the power minus
2.41. Yes.
Sir, 2.415 times 10 to the power minus 3.
Okay. So here I got the moles. So if I multiply these moles with 24 TM cube to get the volume.
Sir, 0.06 dm.
0.06. Okay. Is it the 0.06 or there is some other figure and you have rounded off?
Sir, 0.0579 मैंने राउंड ऑफ किया.
So we got the volume, but there is another thing just which actually come in my mind, that it is an excess, right? So it means that some of the oxygen must be left behind. So we need to know the moles of oxygen as well to find how many oxygen is left behind. So it is 0.1 dm cube divided by 24. Can anybody tell me the answer?
Sir, 4.16 times 10 to the power minus 3.
Here, 4.16 into 10 raised to the power minus 3 are the total moles of oxygen. And in the equation, with 2 moles of AS2O3, 9 moles of oxygen would be reacting. So we have 8.05 exponent minus 4 moles. The mole ratio is 2:9. Okay. So 2:9. The moles of AS2S3 would be are actually 8.05 exponent minus 4 is 2x. So can anybody calculate the value of x and tell me?
Sir, 3.62 times 10 to the power minus 3.
3.62, 10 raised to the power minus 3. So these are the moles that are reacted. These are the initial moles. So if I subtract these, I will get the moles. So can anybody subtract these two and tell me the answer?
Sir, 5.375 times 10 to the power minus 4.
5.375 times 10 raised to the power minus 4, and these are the moles that would react it, right? Actually, these are the moles which are left, because the moles that are reacted are actually over here. So these are the
Yes, sir,
moles
ये remaining.
that are left. So the total volume would be, by adding these two values, so 0.06 plus 5.37 exponent minus 4. Yes, can anybody tell me the answer?
Sir, 0.070.
सर ये 5.37 को पहले वॉल्यूम में नहीं कन्वर्ट करेंगे, आपने मोल्स ही लिख दिए ये.
Yes. Sorry.
सर
So first I
उसको
will,
टोटल वॉल्यूम बना के फिर करेंगे ना.
these are the vol. This is the volume. So I need the volume over here as well. So multiply it with 24 to get the volume. Do it quickly. Yes.
सर फाइनल आंसर ऐड करके 0.0729.
0.072
0.
plus this value.
Sir, 0.0708 आ रहा है.
0.07. The total or the this one?
Sir, final 0.0708.
Okay. ये वैल्यू बताइए, सही है?
सर मार्किंग स्कीम देख लो.
हाँ, आप
सर
check
ये
कर लें.
डिवाइड नहीं होगा.
बेटा मोल्स हैं, द मोल्स को वॉल्यूम में कन्वर्ट करने के लिए 24 से
हो रहा है कॉन्सेंट्रेशन के साथ सर.
ठीक है, गैस है तो इसलिए मोल्स मल्टीप्लाई बाय वॉल्यूम होता है. ओके, सो हियर यहाँ पे आंसर क्या आ रहा है इन दोनों को मल्टीप्लाई करने पे?
सर आंसर आ रहा है सर 0.0129.
0.0129. Okay, so 0.06 plus 0.0129. तो वही 708 आ रहा है. ठीक है, तो 709 आएगा. जी, ये क्लियर है सबको?
यस सर.
ओके अभी we are keeping the class till here only. Who is joining right now? So late. So we will continue this class tomorrow. Okay, I will share the time with you tomorrow. Okay, take care everyone. Allah Hafiz.
Allah Hafiz.